Okay, so our last topic of our function basics unit is direct and inverse variation. Now, direct variation you have done in previous classes, algebra probably. Inverse is likely new. The good news is that math is consistent and they're essentially inverses of each other. So we'll review direct variation, we'll talk about inverse variation. Your guided notes on your Inspire are very general with a couple of practice problems to try, and then we'll get specific in class together. Here we go. So go to page 1-2. And here's a definition of direct variation. Two variables are directly related if the ratio of their values always remains the same. So if I needed to write an equation for a direct variation problem, I would say y equals k times x. K is a constant value, and what I'm asking you to do next is go to the next page and look what happens to the line as I change the value of my constant k. Let's go to page 1-3 and just play for a minute. So here's my slider. You're going to grab it with a closed hand and move. And again, just watch what's happening to the value, or what's happening to the line as you increase k and as you decrease k. And also look around your document and see what else is changing accordingly. And just play for a bit. And when you're done, on page 1-4, I need you to think about what happened to the value of y as x got bigger, increased, and as x got littler, decreased, giving you a hint to look at the table of values. So again, come back over here. If you want to see a table of values, get out of your slider, do a Control-T, look at what's happening to x, or y, sorry, as x increases, and what's happening to y as x decreases, or just look at the graph. So fill that in as you choose. Again, we're going to be very specific tomorrow. Again, what are you noticing about the y-intercept of the line? Look at the y-intercept of the line on page 1-3. No matter what you do to k, what's happening to the y-intercept, or is anything happening to it, or is it staying the same? And talk about that. Again, very general document today. On page 1-6, when does the direct variation line have a positive slope? When does it have a negative slope? Again, making relationships between that very general formula for direct variation and the value of k and what it's doing to your graph. Page 1-7, when can you make the direct variation not appear? And why do you think that's happening? So again, I want you to go back and keep looking at that graph, keep playing, make the line disappear, see what the value of k is, and then think about why that's happening. Again, type your response here. What I'm going to do tomorrow in class, when you come into class, is collect this document from your Inspire. I won't take it off like I do with First 5-5s, but I will be collecting it so that I can look at your responses. Okay, so you do need to go along the video, and you do need to enter your responses so that I can look at them and see what you were thinking as we begin class tomorrow. So make sure you're really paying attention to those sliders and to what's happening with the graph, and make some good assumptions. Okay, so on page 1-9, I give you an example of a direct variation situation. And if you are an hourly employee, that's direct variation. Your total paycheck is equal to your wage times the number of hours you work. The more you work, the more you get paid. That's direct variation. So what I want you to do is think about, in that equation, pay equals wages times hours worked. Which letter would represent the constant? Is it amount you get paid? Is it your wage? Is it the hours you worked? Or do they all vary? Again, answer it, see what you think. We'll go over them tomorrow in class. Okay, so that's it for direct variation. Now, inverse variation is the inverse of direct variation. Two variables are indirectly related or inversely proportional if the product of their values always remains the same. So here I have y equals k divided by x. Some people like to solve for k and call it x times y equals k. I will always write my inverse variation problems in this form. And 90% of what we see in Algebra 2 Trig is inverse variation. So we will really emphasize that this year. So with inverse variation, I want you to look at this graph on page 2-2, use the slider, and see what's happening as k changes. You may want to play with this longer than you did the direct variation because it's new. So this is already a very interesting graph. I have two curves. The name of this graph is a hyperbola. Whenever you have an inverse variation situation, y equals some constant k over x. It's also a rational relationship, a fraction. We get a hyperbola. So again, what we want you to do here is grab that slider, move it back and forth, and see what's happening as k here is getting smaller, and then as k becomes negative. What's going on? Play around, look at what's happening, make some assumptions. So for much of the rest of this document, I want you to look at that graph and think again, just like with direct variation, what's happening to the value of y as x gets bigger and as x gets smaller. If you need to, go back to the graph, click out of the slider, make a table of values, and see what's happening. What quadrants does the graph appear when k is positive? What about when k is negative? Again, type your response there for me to collect in class. For what value of k does the inverse variation not appear? How do you make it disappear, and why do you think that's happening? How does that constant affect the graph as k is positive and bigger? What's happening to the graph compared to when it's negative or smaller? So one last example is for a salaried employee instead of an hourly employee. The amount that he or she earns per hour is inversely proportional to the number of hours worked. You get the same amount of money each week, regardless of how many hours you worked. There's a formula for it. Your hourly rate is your weekly salary divided by the number of hours you worked. And in that equation, try to come up with which variable represents the constant of variation. Your rate, your salary, or the number of hours you worked. And that's it. So again, go through this document, play with the graph and the sliders, fill in the responses, and I will collect them in class tomorrow. Have a good night.